All right, so
Got a blast.
frequency distribution is going to be our focus today. Talking about different frequency, or how to develop frequency distributions and how to organize our data in a way that helps us build that up. So frequency distributions is the title of section 2. Frequency distribution, what the heck is the thing? It shows how a data set is partitioned among several categories, or we're going to call those classes, by listing those classes or categories along with that number of the frequency those data values occur in there. So when I talk about a class, if we're dealing with number data, that class could be people between the age of 12 and 15. And then people between the age of 15 and 18. Our classes are separated that way. And categories could be juniors, seniors, freshmen, sophomores, those sort of things. But a lot of times when we're talking about classes, we're dealing with number data, and we're going to get a range that's in that class. We're going to talk about that today. So frequency distribution or frequency table, you'll see those and hear those as we go. Frequency table, is a little less intimidating word because you've all seen tables where you got headings and columns. That's what we're dealing with. Distribution sounds like a fancy thing, and it kind of is, but it's just a table. Different way of organizing data. Here's an example of some data, some classes. IQ score is the class. The frequency is listed on the left. So there's an example of a frequency table out of that. And inside of that, lower class limits. They're highlighted there, circled in red, but lower class limits. So notice IQ score from 50 to 69, and then the next class starts at the next number, 70. Goes up to 89, and then the next class starts at 90. So when you're dealing with numerical data there, no gaps in your classes, okay, in your range there, okay? Lower class limits is the smallest number that can actually be in that class. So when you talk about lower class limits, that's the smallest number that's in there, okay? And then go from there. Somebody be panicking and run away from this. Just give me that. Again, I'll share the PowerPoints on Classroom. That, and I'll also share the link to the YouTube playlist for all our lectures. So, all right. Good. All right. IQ scores, lower class limits. Lowest number that can be in that particular category or class. That's another thing. IQ score and the frequency distribution over there on the right. The upper class limits, that's the largest number that can be in that group. The largest numbers that can actually belong to the different classes. So IQ scores are not continuous in that you don't have a 14.2 IQ. Hopefully you all have 100 and something IQ, but it's not. They generally do not do decimals with those. It's not that accurate, not precise into that. So they're not continuous data, but definitely variable numbers. Okay. So upper class limits, lower class limits. Those are for our classes. Where they use the word categories sometimes. Classes and categories interchangeable depending on what data you're dealing with. Number data, you usually call them classes. Okay. Class boundaries, 49 class boundaries are numbers that separate our classes, but without gaps. So again, no gaps in that, and in between one class to the next. So if you're going to separate them, you've got to Make sure the data doesn't have gaps. What are these red numbers here on the left? Where are they coming from? What are those? Look at the classes that are set up there. We got 50 to 69, 70 to 89, 90 to 109, 110 to 129, 130 to 149. What are the red numbers? What's special about them? Okay, so the 49.5 is below the 50, right? And then 69.5 is between 69 and 70, exactly, right? And with those are boundaries. Anything above that is going to go into the next class, okay? Anything below that is going to, or equal to that or below, is going to stay in that class. So those class boundaries, you got to, even though IQ doesn't do decimals, you've got to keep that in mind to get a better general idea of class boundaries. Class boundaries are where are you going to change over to the next category or next class? And that number is where you change. So at 49.5, rules for rounding will say that goes up, so we'll go up. We just got to make a decision which way we're going to go. We're going to just round like normal numbers because this is math. So then 69.5 will go up to 70, but a 69.4 stays down in the class before that. So be diligent about that. And if you've got data that does have decimal places in there when you're creating tables of classes. Okay. All right. Class midpoints are, what's a midpoint? It's an obvious word. Midpoints are halfway, right? So 59.5 is where? Right in the middle of 50 and 69. It's the midpoint of that class. Okay? Sum up your class values of your class limits and then divide by 2. Lower class limit plus the upper class limit, divide by 2.
What's it take to get an IQ score of 50? How hard do you have to try to get that low of a score?
Some people are not as blessed as you.
No, I've never heard of anybody. I didn't know if it was like a common thing.
There are people you see every day that have. I say that.
There's some more common sense than those ones.
Not necessarily. I'll let you do your own Google research about what IQ score says about IQ. It's a measurement of brain power, but doesn't necessarily go depending on the questioning. Again, bias could cause you to have a lower one or a higher one, depending on the assessment. Okay, so class midpoints, middle of the class, upper limit, lower limit, add together, divide by 2. Class width, difference between the lower class limit and or 2 consecutive lower class limits, so 70 minus 50, that's where the 20 is coming from. Okay, so difference between 2 consecutive lower class limits or 2 consecutive lower class boundaries. Remember, our boundaries were those numbers. 69.5 minus 49.5, still 20. Class width, 70 minus 50, still 20. So whether you use that lower class limit or the class boundary, you should get the same number for class width. That's always a good checking spot. Make sure you're doing things correctly. The class width, important thing, be able to calculate that. All right. Reasons for constructing those frequency distributions. Why the heck do we need them? Large data sets are easily summarized with frequency distributions. So you've got a ton of data. It's, instead of looking at each piece individually, it's better to kind of group them together in some way. Those classes and frequency of falling within a class makes the data kind of a little bit more manageable Okay. So large data sets can be summarized. We can analyze the nature of the data. So if we can get a frequency distribution, we can get an idea of where most things lie. If you look back at the IQ table, just looking at that one, where do most IQs lie? In those two, the second and the third class, right? That's easily seen there. If you had a spreadsheet full of everybody in the school's IQs, and that's all you had, you couldn't make that generalization really fast. A frequency distribution makes that an easy and a quick assessment of that. That, oh, we know most people, are going to be somewhere between 70 and 109 as an IQ. We can figure that the average is probably going to be somewhere around a 90 IQ. 92 to 90 to 95, something around that, based on those numbers. Okay, so we can analyze the nature of the data, summarize, and make those assessments fairly quickly. We've got a frequency distribution, and technology can help you do that sometimes. And a basis for constructing important graphs. Important graphs would be maybe a plot of all the data. If we know it's going to be shaped like a certain way, if we plot the data and it doesn't end up that shape, we probably know something went wrong there. So important graphs, we can do pie graphs, we can do a lot of different ways of representing our data based on a frequency distribution. We're always trying to make a conclusion, and some of those graphs are important for making conclusions. Okay. Good with that one. So a frequency distribution is one of the first things that you can do with your data to help you summarize it and get a general idea of what's happening. So number one is summarize. Number two, general idea to analyze it, and then a basis for constructing other graphs out of that. So a frequency distribution is going to help us. We'll see that next section. We talk about histograms. That's going to be built off of a frequency distribution. If you can't make a frequency distribution, you're going to have trouble making a histogram because they're directly related. Okay. All right, constructing a frequency distribution. So here we go. We need to first determine how many classes that we have. Okay, classes normally should be between between 5 and 20. Okay, 5 classes to 20 classes. If you get over 20, you're probably separating your data too much and making the classes too small. Okay, 5 classes to 20 classes. Okay, so each, the line on frequency, your frequency table should not be 2 pages long. If it is, you're probably separating your data too much. Okay? So important, remember that, between 5 and 20 classes. Okay? Calculate the class width. Okay, class width, this is how you're going to calculate it. You're going to have to do this. Okay? Maximum value minus the minimum value divided by the number of classes. Okay, so you take your highest data point, IQ of 162. It's, probably Coach Mac or something like that. Something annoying, or Miss Wilder, she probably's got a really high one. Pretty sharp. Minus the lowest IQ, which would probably be around mine. And then you divide that in how many classes you want to have. Okay. Remember, that needs to be between 5 and 20. And then you're going to round up to that. So if you divide that and it comes to, it doesn't go evenly, very likely doesn't, round up on the number of classes that you make. Okay? Starting point. Okay, this is where you're going to, after you've done these 2 things, determine the number of classes, got your class width, choose the minimum data value or a convenient value below the first lower class limit. Okay? choose a minimum data value or a convenient value below it for the first lower class limit. So if your lowest number in your data, let's say it's a 20, then you're going to start making your classes at that 20 or a convenient number just below that, depending on what your highest value is. Okay? So you look at your data, you get the lowest number, the lowest value, the minimum value that goes back up here, that minimum value that you use right there. Most of the time, you can just make that your lower class limit for that first class on your frequency table. Okay. Or if your lowest number is 21, you might want to make your lower class limit 20, and then go by tens or something, depending on how many classes you want to make. You can kind of make it different according to the data that you got. All right. Using the first lower class limit and the class width, which you've already calculated, class width, maximum value minus minimum value divided by the number of classes. Proceed, you're going to go ahead and make your other lower class limits. So if you started at 20 and you know your class width is going to be 10, you're just going to keep making those on up to the next one. Okay. Lower class limit for first class is 20. The next one, if the class width is 10, 30, 40, 50, 60, and at least to 70, because you got to have 5 classes, right? 5 classes. Unless the problem specifies to only have less than that. Okay? You're going to get problems that are going to say, create a frequency distribution with this number of classes. You got to work on that. Okay. All right. List the lower class limits in a vertical column and enter the upper class limits. Okay. So if my lower class limit is 20 and my class width is 10, I'm going to go from 20 to 29. The next class would be 30 to 39, 40 to 49. Okay. All the way up to you've got all the classes that you need. Step by step on building a frequency table or frequency distribution. We're getting through here. List the lower class limits in the vertical column and enter the upper class limits out of that. So that's where you would start making that table. 20, 29, 30, 39, 40, 40, 50. All right. Good. Video thing is covering up the last one. Whoops. All right. Last thing we're gonna on this list, we're gonna take each individual data value and put it in the class. Tally marks. Count them up. Okay. Tally marks or just count them. Put each individual data point in a class so that you can create that frequency table. Oh, how many histograms you've made over the course of your life. That's what we're building up to. Next section is about histograms. And this section is building up the frequency table idea so that making a histogram is quite possibly the easiest thing to do. Okay. Idea here. Get your frequency distribution or frequency table, get it correct, then a histogram is easy. Okay. All right. We good? Relative frequency distribution. Okay, so this is something we're going to calculate over time here as we're doing some problems here. It's one of the things that you're going to have to do. This is a little bit of math, but it's not anything to just blow away hard math here. Includes the same class limits as the frequency distribution, but the frequency of a class is replaced with a relative frequency or a proportion of that, or a percentage frequency. Okay, so for a relative frequency, so you can have, you can have a frequency table, and you got actually numbers there, but you can also have a relative frequency, which kind of gets us to the idea of maybe a pie graph. The idea here, class frequency divided by the sum of all of the frequencies. Okay, so you had data points, and you had 5, 7, 14, 6, and 2, or something like that. If you had that in your table. So these are your frequencies. You could do a relative frequency by taking that class frequency and divide it by the sum of all frequencies. So 5 divided by the sum of all these. So that'd be 25, 32, 34. So 5 out of 34. 6 out of 34. 14 out of 34. 7 out of 34. That's your relative frequency. And then you get a percentage frequency. By just converting those fractions into percentages. Not hard math again, very basic math stuff. So convert these into decimals, and then do the decimal place twice. Okay. So you take that fraction times 100%. So easy thing to do. So it's all built off setting up your classes, getting the tally right, and your frequency table built, and then you can build the relative frequency or the percentage frequency. Easy stuff. Okay, so here's an example using IQ where they've done those things. The IQ score, that's the same data that we had earlier, and then they did the relative frequency or the percentage frequency. So there are those numbers. They went 2 decimal or 1 decimal place on that, because there were no decimal places here. So just make the numbers work out. What should the percentages add up to be? Really, really close to 100%, if not exactly 100%. Okay, so when you're looking at that, I'm not saying, change the data or anything, but when you add up those percentages, if it adds up to 85%, something's wrong. If it adds up to 99%, probably okay. There was just a rounding thing that happened with the decimals. Okay, so it's got to add up to 100% or really, really close to 100%. Okay, it's not close to 100. 95 is not close to 100. Okay, that's off by too much. Okay. So we've got to be the percentages have got to add up close to 100. Okay. Cumulative frequency is just adding up as you go. So like for this one, the 2 and the 33 has to be 35. It's a cumulative frequency. And then 35 plus 35 is 70, plus 7 is 77, plus the 1 is 78. So it's a cumulative. It adds up as it goes. Again, we're building up this table to help us build important other graphs. Sometimes when you want to know how many people are under, have an IQ less than 129 or less than 130. That's a better way to say it for the class limits here. 77 people, just by looking at that table. You can quickly tell that. So we're building up through a frequency distribution or frequency table, we're building up things to help us make conclusions or make some statements about our data. out of that. So a cumulative frequency is just adding up your frequencies as you go. Very, very simple math. All right. Later on, we're going to build off of that as we go. We're going to talk about a normal distribution, which is what happens with a normal distribution. I actually made one there, pretty close on that class that I came up with there. The normal distribution, we talked about that normal curve yesterday a little bit, where it was the bell-shaped curve, that sort of thing, where the average, most of your data is here. You got some here and here. Y'all may have saw that a little bit down here. I don't know, depending on what year you had it. Do you know?
For 30 seconds. We've got the force of girls digging snuff and
We talked about that.
then.
She said she was trying. A little slack. But we're going to talk about that bell curve. There's, we spent a good time talking about that and some various things. With a normal distribution, the frequencies start low, like here mine are 5, 6, 14, 7, 2. They start low, they get large in the middle, and then they're low at the end. That's how a normal distribution kind of follows that. A skewed distribution, depending on which way it's skewed, the bigger parts are either at the low end or the high end. That's what skewed means. We can talk about those. A normal distribution is symmetric, meaning it's about the same on either side of the middle. The mean there, mirror images on those things. So you can look at a frequency distribution and get a general idea, is this pretty close to a normal distribution? Being able to do that, just to kind of give you a heads up, and guys, this is stats, it's a little different than algebra. That frequency distribution is the basis of starting all the decision-making process that you're going to have to do in later on chapters. That depending on what kind of distribution it is, it tells you what kind of tests to do or what things you are allowed to do to that data and find out some things about it. Okay, so frequency tables, frequency distributions really are the basis of everything that we're going to get to here, and we're going to do some by hand, and we're going to use some technology to build some and that sort of thing. Dealing with gaps in a frequency table. The presence of gaps is not good. That if there is a gap, let's say you had a class that had 0 in the frequency, then what that kind of tells you is there may be 2 different populations going on, that this group should be studied together, and then there's a gap, and this other group should be studied separately. Okay. That last statement there is it's kind of sticky in the fact that just because there are different populations doesn't mean there will be gaps. If there are gaps, it probably does mean they're different populations. But you look at the data, and when you look at the frequency distribution, you kind of make those decisions. That's kind of what they're getting at here. Is if there are gaps, there's probably more. There's different populations in there. If there are different populations, that doesn't necessarily mean that there are going to be gaps in the data. You think about if I survey or find out information about you guys as seniors, the whole senior class, and then I find out information about the 9th graders, that's 2 different populations, right? But there may not necessarily be gaps in the data. If I found out all that information and I realize that there are gaps in the data, then that should tell me, oh wait, there's 2 different populations here. The freshmen seem to all answer this way. The 12th graders seem to all answer this way about things. So a lot of that stuff comes out when you start making those frequency distributions and looking at the data. So gaps you got to be careful of those. All right. Table on the next slide, just giving you a heads up what you're going to be looking at. We're looking at a frequency distribution of randomly selected pennies, so the coins, not people named Penny. Okay, weights of pennies, and then pennies made. Here's what you may or may not know: pennies made before 1983 had a different metallic makeup than the ones made after that, because at this point in time, copper, the price changed to where to make a penny, it cost them more than 1 cent to make a penny with that, or the metallic makeup of that. So pennies after that will change to be copper-plated zinc disc instead of, yeah. So it's not very much copper in a penny anymore. There are actually people. I watched a whole show on this. This is how exciting my life is. I watched a whole show on Discovery about people who are saving pre-1983 pennies, and like there's people that rent them a storage unit, and they've got barrels of pre-1983 pennies because of the copper in them, and it's worth. And at some point in life, maybe they will decide to cash them in, and that copper will get recycled. But that barrel of pennies is worth more than 1 cent per penny because of the metal value out of that. So there are people that do that. All right, so when we look at this data, what we see with their frequency table that they've developed here, they've got classes here, the weight of those pennies from 2.4 to, and then the next class is 2.5, 2.6, and so on. They go through that, and notice the large gap in between 2.9 and 2.5. That's what tells you, okay, well, these are different pennies. So based on that weight, you would be able to separate the two different types of pennies based on the weight. Two different populations. That's what they're after. The presence of gaps, it suggests that there are two different things going on. So that big gap in between is things we notice with frequency distribution. If we were looking at a spreadsheet with all these different weights, is there much difference in something that weighs 2.4 grams and something that weighs 3.1 grams? You couldn't put it in your hand and tell the difference. Yeah, 0.6 grams is nothing. But when you look at the data, we see the gap in those and we realize, oh, these pennies are not the same. So I've done some activities before with pennies and the weight of them and not separating them by what year they were, and it can really confound your data. Remember we talked about that in chapter 1, confounding things. If you're looking for something to happen, but you're dealing with two different populations in there and you're not expecting it, it confounds the thing and it really messes up the data out of that. So, section 2, that's our stuff. This is what we've got. Some time left today, but you can go ahead and get started on your work if you want to. I would suggest that would be a good idea. Page 51, 1 through 34 is where you're going to answer questions from. A little bit more math stuff in here. You're going to have to build some frequency tables and things. Some of it just takes some time to do. So you're going to have some time today. We'll work tomorrow, and then we might make it. Tomorrow's Friday, right? Okay. We might make a decision tomorrow. So be thinking about this, and we'll make a decision when we come in tomorrow whether we want a quiz at the end of the class tomorrow so that we don't have a quiz on Monday when we come in, or if you want to wait till Monday. So I'll be thinking about that. We'll poll Monday or tomorrow when we come in. I know what I vote for. It doesn't bother me what you vote for. So I'll do it. Okay. Yeah, sure.